Okay, let's look at 34, and this is, we already kind of got into special cases with difference of two squares, and 34 is also a difference of two squares. It's a difference, subtraction, it's a binomial. I can square n to get n squared, I can square 3 to get 9, so that would factor into two binomials. What do I square to get n squared? N goes in the first one in each. What do I square to get 9? 3. One's a plus, and one's a minus. Okay, and that one we didn't factor out anything. So let's go down to 36 then. So that's a binomial, but it's not a difference of two squares, because 2p squared, we have p squared, but we have the 2 out in front, and 8's not a perfect square either. But I can take a 2 out, so you want to take out a 2 first, and then I'm left with p squared minus 4. And this is similar to an earlier one I did in the video. This is now a difference of two squares, so that's going to factor into your two binomials. P in the first spot, whatever I square to get that, whatever I square to get 4, which is 2. Goes here and here. One's a plus, one's a minus, but this one you got to carry down the 2 and have that as part of your factored answer. Okay, let's keep going here and let's go down. Now we get to something new, factoring sums and differences of two cubes. And on your reference sheet I have some patterns for sums and differences of cubes. Okay, so basically the pattern is this. If you have a cubed plus b cubed, the pattern that it factors into is a binomial and a trinomial. It's a plus b, and then inside the trinomial is a squared minus a times b and plus b squared. If you have a difference of two cubes, in other words, you write it this way, so you have a cubed minus b cubed. The only thing that changes, it's going to be a binomial and a trinomial, is a minus b, and then it's a squared plus ab and plus b squared. That's if it's a difference of two cubes. And you've not factored these are new, but there's patterns you got to follow. Now the key thing is you have to write it, what your original problem is, figure out what you cube to get each of those terms. So if I look at 41, the first one here, I notice that I have a sum, and I can cube x to get x cubed, and I can cube 2 to get 8, because 8's a perfect cube. 2 times 2 times 2 is 8. So I need to first write this as x, or the thing I cubed to get x cubed, out in front, and then over here, what do I cube to get this 8? Well, I cube 2. So I want to write it this way. That's this top thing right here. You have to write it that, and then you just plug into your pattern that we're going to follow here. So if I plug that in, I'm looking at this right now. It's going to be a binomial times a trinomial. And notice, a was what's inside the first thing. So this is the first thing, so that's x. And then it's plus b. Well, b is what's inside the second thing, inside the second set of parentheses. So that is a 2 right there. And then I come inside here and I say, okay, this has to be a squared. So this is my a right here, and this is my b that I'm following for the pattern. So this needs to be x squared, because it says you have to square whatever that is, minus a times b would be multiplying x times 2, and we're going to write that as 2x. And then plus b squared, so it's plus. Notice b is 2, so I really have 2 squared, except for we don't want to leave it here as 2 squared. We actually want to square 2. So 2 squared is 4, so we want to write that as plus 4. Okay, so you're just following the pattern that I have on your reference sheet.